Hello, class. Good morning, good evening, whenever you're watching this video. This is on acid-base 2 lab. I do apologize for getting this out late to you. Again, some things are occurring, and this is the only free time I have. Sure, share my screen. So, here's the worksheet. Like always, dispelling the exact same information. I'm going to be grading this based off completion. I'm not really going to grade this based off accuracy. So there's that. The key of the matter, this. So the solutions we used, one was a strong base, an AOH, and it had a concentration of 0.100 molarity. Was there bottle information? There was not. Here was an unknown. Oops. Unknown. That's misspelled. There you go. Unknown. And there was bottle information if you guys recorded that. If not, you can put no there. That's fine. So here, you're going to need at least 3 graphs. One for your rapid titration, one for your accurate titrations, and one that shows the derivative method. I know some of you do not record the volume, the pH, or do record any information whatsoever. I'm going to be giving you data that I received from a student outside our class, so that way you guys still can do work. So here is theirs. This is their rapid titration. This is their accurate 1 and accurate 2. They got 2 accurates done. That's why I'm going to give it to you guys so you have more information to do. So with Excel, you can take the 2, go to Insert, go to Chart, and go to here, and you can see a diprotic acid titration curve. You need to figure out what the equivalence points are. So if using Excel, you can use the graphical method, which basically you're going to, with a steadier hand, draw a line here, draw a line here, draw a line about in the middle point, and right there you would see your equivalence point is roughly. Same thing over here, same thing here, and then you draw a line. Equivalence point would be right around probably here or so. That's how you do graphical method. And then you just look at the point right there. That would be the equivalence point. Or you could take the information from Excel, put it into Logger Pro, get this nice beauty right here. It's the exact same graph. Again, we're going to do the derivative method via Logger Excel with calculus. Data, you're going to go to get into data, new calculated column. We call it derivative. This is exactly the same thing we did with the first acid-base one. Functions, calculus, derivative, quotation marks, y, quotation marks, comma, quotation marks, x. So this is y, the function of x. We'll hit done, drag, click on, it's on there. Go to graph options. We go to axis options. We hit this button. Move the derivative on the right axis. And ta-da! If you noticed, mine was had a top of 3.2 that allows it to grow up like this. Yours might not have it. You have to play with that number until it crosses. Now I know that my equivalence point is between these 2 places, which would be, for example, right there and right there. There's my equivalence points. So what you're going to do with this information, you're going to copy this graph or copy the Excel graph, whatever one you want, and paste it in. Ta-da! Boom. And making sure it's labeled. This one's unlabeled. You should be able to label it. If you need help, refer to acid-base 1, but it's pretty simple. Graph options, label Y, label X. There we go. That type of stuff. going to need graphs for the rapid, the accurate, and then there's the rapid again. Okay. You do that there, the exact same thing, either the Excel method, which is the graphical method, or you use Logger Pro, which is the calculus derivative method. If you want more accurate data, I would recommend the derivative method. It just makes life easier. If you want to use the graphical, it's easier but less accurate, use that method. So boom, boom, boom. Okay. Then we did 2 runs. 1, 2 in my class. If you're using another person's data, you might have 3 runs. Equivalence point. The equivalence point is going to be your pKa value. So, for example, like I said, right here would be the equivalence point, which has a volume of 15.03 and a pH of 9.21. That 9.21 is going to be the pKa, which is also just the pH. So we're just going to type in 15.1 milliliters, and the pH was equal to 9. Oops. 103, 9.21. There you go. You're gonna do that for both equivalence points. Technically, this one should be over here. My bad. There you go. Put that for both of those. Boom. Tell me what method you use. Was it graphical? Was it derivative method? Here we have runs of pKa. This basically is going to be the pH, because pH is pKa in equivalence points. So, for example, 9.21. That was going to be the pKa. So 9.21. Whatever you add them together, divide by the total amount, and your average right there. Part 4, based off your averages, right? You're gonna put those here. Averages go here. You're going to have to go online and figure out 2 diprotic acids that have very similar ones to see, hey, is it this one or this one? Don't worry about being right or wrong. If you do this, you'll get points. Then report where you found the information from. So give me 1 second. I'm going to fill in the rest of this information for some of you guys. I know some of you guys want it be filled out as much as possible. So give me 1 second. Hello, welcome back. I just filled in this information to make sure you understand what's going on. You add the run 1, run 2 pKa, divide by 2, get that. You would enter it down here. I know some of you guys get confused and want step by step, so I'm just showing you right there. Again, you have to figure out what acid online's doing that. So about the post-lab questions, because these are probably the hardest part about the entire lab. The rest of it isn't too bad. Maybe entering the data is a bit confusing. Okay. So for the diprotic acid, why does the ionization of water have a greater impact on the pH at the segment equivalence point? Well, if you go look, the difference between pKa1 and pKa2 is dramatic, right? This is closer to 1, which means it's pretty strong. This is further away, which means it's pretty weak, right? So the ionization of water, or water becoming an acid and base, has a higher effect on the second proton, because water will act more as an acid than the base. It's going to affect it because the pKa for the second one is so small compared to the first one. That's why. Okay. Well, we had to calculate Ka, and you guys should know this from lecture, but pKa is equal to the negative log of Ka. To solve for Ka, you just take base 10 negative log of pKa. Boom. That's how you're going to solve for Ka. That's the first half. Then you're going to look and tell me which one's favored, reactants or products. Remember, if your Ka is equal to 1 or more than 1, you have a strong acid. It's less than 1,
you have a weak acid. When the strong acid associate 100%, so products are super favorable. With things less than Ka of 1, it's a toss-up. If it's dramatically small, it's going to be reactants are favored because it's not going to want to react as an acid. It's going to want to stay, it's going to act as a base. That makes sense. Remember, the smaller the Ka, so the larger the Ka value, the stronger it is. The smaller the pKa value, the stronger it is. Okay. So many reactions have involved the removal of a hydrogen. Hint, hint, wink, wink. That's an acid. Acids remove hydrogen. How can the pKa value be used to predict this? Remember, I just told you guys, the lower a pKa value or the higher a Ka value is, dictates how strong the acid is. Stronger acids will almost always donate their protons and thus shift the reaction forward. So if you can tell based off a substance's Ka value, if it's going to act as an acid or base. The equivalence point for a weak acid is often at pH 7. Well, why? Because most of the time when we donate with weak acids, they can't neutralize the base 100%. Thus, some of the base is left over, making the pH higher, equivalence point higher than it needs to be. This one should be obvious to you guys, but if not, remember that Kw, which is ionization for water, is equal to Ka times Kb. So I have to put that one. So that should be known. Unless some of you guys had trouble with buffers, we'll cover that before the next final. Okay. Under what conditions the pH of a neutral solution will not be 7? Right? How does this impact the relationship between this? Well, remember, the Ka is equal to, sorry, Kw is equal to 1 times 10 to the negative 14th, right? That's only true at 25 degrees Celsius. Remember, K, if you change temperature even a little bit, it affects the entire equation. So if you change temperature, either raise it by a lot or lower it by a lot, neutral solution won't be at pH 7 anymore. It'll be higher or lower depending on the new temperature you guys have it at. Now, this isn't going to affect you guys too much in lecture because we always keep it at 25 degrees Celsius because the numbers make it look nice and pretty. But in reality, some things are not going to take place at 25 degrees Celsius. Sometimes acid and bases react very violently and heat up very quickly, which changes the pH concentration. So that's what conditions would be that increased temperature would affect this right here. And that's pretty much it. It's a pretty simple lab. The hardest part is me entering your data into Excel and then converting them into Augur Pro or using the graphical method, but doing all of that. If you're one of my several groups who do not have the information to do it because you correct record the information, I will also post my Excel graph, my Excels of the rapid and accurate titrations. Please note that if you're going to use this information, I am going to have to grade you a bit harder because I basically just gave you a good chunk of the information and data for you right then and there. And to be fair to everyone else, I am going to grade you a bit harder, just by a bit, because I expect you guys to understand it because you're using someone else's data that's pretty good. I worked with this student on their information and they have amazing data. So you should get good results. If you get poor results, it means you messed up somewhere and I know it. Sorry about that. It's just how it's going to be fair to everyone else. So I'm trying to keep it fair to everyone else who did the lab. Okay. Other than that, if you have questions, please let me know. Okay, I'm going to hop off now.